Hello everyone. So welcome back to another video. So today I'm letting Python do something most people would never trust a computer with. I'm letting it pick my entire stock portfolio. And I'm going to be doing this using real S&P 500 data, a bit of math, and a powerful optimization library that we are going to install here. So I'm going to build a program that calculates expected returns, risk, volatility, and even the Sharpe ratio, and then let it tell me exactly how many shares of each stock to buy. So let's go ahead and get to it, and let's see if the machine can beat the human. All right, and we're going to, of course, be building the final portfolio. We're going to show the optimizations of it, and yeah, let's get started. So I'm currently on Google's website. It's called colab.research.google.com because it makes it easy to get started programming in Python. So if you want to code along with me, just go to this website and then log in with your Google account to get started writing your Python code. And also don't forget to hit that subscribe and that like button for more videos like this. All right, so again, the first thing that I'm going to do is install the package that we need. So I'm going to type pip install, and I'm going to install portfolio opt. Okay, so let's go ahead and run this cell. And there we go. It's looking good. So while this is running, I'm going to click this code button in the top left to create a new cell. And let's see, did it finish? Yes, it did. So we get a little check mark. So we're good there. Okay, so I'm going to import some of the libraries that we need. So we're going to import the libraries. All right, so I'm going to import pandas as PD, and this will be for data manipulation and for data frames. And next I want to import numpy as NP, and this will be for numerical operations. All right, so let's just go ahead and just run this cell as well. Let's create a new one. Okay, now let's go ahead and store our data into a data frame. So here I'm just going to type store the data, and I'm going to create a variable called df, which will be short for data frame. I'm going to set it equal to pd.read_csv, left parentheses, right parentheses, and we're going to input the name of the file here. So if I come over here to the left, we're going to open up this icon that looks like a folder called files. And here you can see I've already uploaded the S&P 500 close price.csv data. And if you want to upload your own, you can just click this upload button here to upload your own file. All right, so let's go ahead and put that name here. So that's SP500 underscore close.csv. And let's take a look at this file. So I'm just going to double click on it. Let's exit the left pane. Let's also see if we can bring this on over a little bit. Okay, and we can take a look at the data. So this data set has the date column, and then it has a bunch of stock symbols that are in the S&P 500. So if we just scroll over here, we're going to see a bunch of them like AMD, and it is not necessarily in alphabetical order. If I keep scrolling over, let's see what else that we might be interested in. So we can see Google or Alphabet, GOOGL and GOOG, and so on and so forth. We have Amazon here. All right. So that's kind of what the data looks like. And it looks like we're starting on January 2nd, 2019. And let's see if we can go, I added more pages here. So let's scroll down. Let's go to 19. Okay. So it looks like it ends on May 29th, 2026. All right. So that looks good. All righty. Uh-oh. Okay. Let's see what else we got here. There we go. Perfect. So 2019 it starts, and then it ends in May of, let's click it again. Just give it some time. All right, May 29th of 2026. All right. So that's our data. That's kind of what it looks like. And here we're storing that data into our data frame called df. Okay. All right, next let's go ahead and set the date as the index. So we saw the date column there in the data set. And so here I'm going to put some comments. We're going to set the data, or sorry, we're going to set the date as the index. All right, so to do this, we just set df equal to df.set underscore index, left parentheses, right parentheses, and then in here we're going to put pd dot date time index. All right, and then within these parentheses, we're going to put df date. So we're going to use that date column and then type values here. And that should convert the date column to date time index. All right. Okay, what else do we want to do? Let's remove the date column now, since it's no longer needed after setting the index. So here we're going to remove the date column. So we are going to type here df.drop, and we're going to drop on the axis equal to 1. So that's on the columns. And I need to tell it what to drop. So here we're going to put columns equal, and we're only going to use one column, right? So we're going to use that date column. Okay. And we're going to set in place equal to true. So it does it on the data set. And I think that'll do it. And let's see, what else do we want to do with this data? So we want to, transform it, manipulate it a little bit here. Let's drop or remove columns with any missing values. All right. So we're going to remove columns with missing values. So we just set df equal to df dot drop in A. And then we're going to set axis equal to 1 for columns. And then how will be equal to any. So we're going to remove any missing values. Okay, and then I want to display the clean data. So I'm just going to type df here. And let's run this, and hopefully I didn't make any mistakes. Okay, perfect. So now we have our new data set here, our clean data set. So you can see the date column is gone. We have the data as the indices or the index, and there shouldn't be any missing values in this data set. Okay, so it looks good. 1,862 rows and 478 columns in this data set. All right, so let's go ahead and create a new cell. All right, so now in this cell, I want to get the assets or the tickers. I want to get the column names of the stock symbols. So here's going to say get the assets, and I'm going to create a variable called assets and set it equal to df.columns. Okay, and I think that's good enough here. Let's just run that. All right, and if you want to take a look at it, we just display assets. So I can just put assets here, and I'll make that a capital D. Let's run this, and there we go. So these are our stock symbols here. All right, let's create a new cell. Okay, so now in this cell, we want to optimize our portfolio. So we're going to need to import some things. So we're going to import the portfolio optimization module for optimizing. All right, so from pi or pip fop dot efficient underscore frontier, I'm going to import efficient frontier. Okay, next from pi or pip opt, I want to import risk underscore models, and also want to import expected underscore returns. Okay, so hopefully everything there works as expected. Okay, so next I want to calculate the expected annualized returns using the historical mean returns. And so I'm going to create a variable called mu, which usually is used for mean. And I'm going to set it equal to expected underscore returns dot mean historical return, left parentheses, right parentheses. And in here, we're going to put in our data set. So that's DF, or our data frame. Okay, and this should give us our expected annualized returns. All right, next I want to calculate the annualized sample covariance matrix of daily returns. All right, so usually we'll use S, or capital S, for sample. So I'm going to create a variable called S, set it equal to risk underscore models dot sample underscore code. And we're going to have to put in our data set here. So we put in DF there. Okay, so that should give us our covariance matrix. All right, next we're going to optimize for the maximum Sharpe ratio. So I'm just going to put optimize for max Sharpe ratio. Okay, so I'm going to create a variable called EF, and this will be short for efficient frontier. And I'm going to set it equal to efficient frontier, left parentheses, right parentheses. And so this right here will create the efficient frontier object. And we need to add in two parameters. We need to add in our mean and our sample covariance. So that's S. And then I'm going to create a variable called weights and set it equal to EF dot max underscore Sharpe, left parentheses, right parentheses. So this method should compute the optimal weights here for our portfolio. All right. So now let's clean the weights. So let's create a variable called clean underscore weights and set it equal to EF dot clean underscore weights, left parentheses, right parentheses. And this right here will create the efficient, this right here will remove tiny weights for readability. Okay. And again, the whole point of this video is so that we can create a portfolio using the stock symbols in the S&P 500 data set that we have here. And we're going to try to get the best Sharpe ratio. We're going to try to get the best volatility, the best expected returns, and we're going to basically try to see what number or what the allocations are of the stocks that we need based off of a certain amount of money that we want to put in this portfolio. Okay. All right. So with all that being said, we have our clean weights here. And this right here will again remove tiny weights for readability. And maybe I'll put that here. Remove tiny weights. All right. Next, let's go ahead and print those clean weights. Clean underscore weights. And I think that looks good. Let's run this for now, just see what it looks like and give it some time. Okay, so there we go. So we have our stock symbols and the weights here, which doesn't look very intuitive right now, right? It looks kind of strange, but that's okay because we're going to clean all of this up and you won't see all of these stock symbols with these zeros later on because we obviously won't have any MMM in this case. We won't have any AOS stocks in our portfolio in this case here. All right. Okay, so let's continue. All right, so let's show the expected returns, the volatility, and the Sharpe ratio. And I'll put that in comments here as well. Show the expected returns, volatility, hopefully I'm spelling that correctly, and Sharpe ratio. Okay, so that's EF. We just have to type EF dot, and EF is our efficient frontier. So we just have to type EF dot portfolio underscore performance, left parentheses, right parentheses, and then set verbose equal to true. Okay, and now let's run this again. And for those of you who don't know, the expected returns is the average amount of money in our investment that we're likely to make over time. So in this case, the expected return is 42.9%. So we put $100 into this portfolio that it's telling us to create, then we should make $42.90 back. That's the expected annual return. All right, the volatility is 20.6%, and volatility is basically a measure of how much an investment's price moves up or it moves down over time. And then we have the Sharpe ratio, and the Sharpe ratio measures how much return an investment generates for each unit of risk that we take. And a Sharpe ratio above 1 is considered good, above 2 is considered excellent, and above 3 is exceptional. And so here, this portfolio would be a Sharpe ratio of 2.08. So this is excellent. It's an excellent portfolio. And we don't see the weights here just yet because they're probably further down. But it looks like it's not telling us to get any Google, any Amazon, so on and so forth. But we're going to clean all this up, like I said. So let's just continue for now. Let's create a new cell. And now in this cell, what we're going to do is get those allocations, get those discrete allocations of how many of each stock symbol do we need given some amount in our portfolio. So I need to import some libraries for this. Or I think I just need to import, well, I just need to import one library, but we need to import some more methods and functions, some more functions. All right, so let's go ahead and do that now. So I'm going to import the discrete allocation tools. So from pip fopt dot discrete allocation, we're going to import our discrete allocation function, and we're going to also import the function get latest prices. Okay. So now let's go ahead and give our portfolio a value. So I'm going to create a variable called portfolio underscore val and set it equal to, we'll say 5,000. So we're going to put $5,000 into this portfolio. Okay. This is the total amount to invest. And then we're going to create a variable called latest underscore prices. And we're going to set this equal to that function get underscore latest underscore prices, left parentheses, right parentheses. So this should get the most recent price of each stock in our data set. And then we're going to create a variable called weights and set it equal to our cleaned weights that we created earlier. And that's cleaned underscore weight. Cleaned underscore weights. Okay. All right, so I think that looks good. Let's go ahead and create the discrete allocation object. So I'm going to create a variable called DA, which will be short for discrete allocation. We're going to set it equal to discrete allocation, left parentheses, right parentheses. And here we're going to put in our weights. We're going to put in the latest prices. And then we're going to put in our total underscore portfolio underscore value. So that's the portfolio underscore val, or $5,000, right? And for some reason it doesn't like, I guess it doesn't like discrete allocation for some reason. Let's see, did I misspell something? Discrete. Oh, nope, it's runtime disconnected. Okay. All right, so this looks good so far, but lost connection. So we have to come back up here and let's just rerun everything. So we're going to rerun this to install the package. All right. And then we're going to come down here We're going to rerun this and rerun this just in case. It looks like everything is good now. We're going to rerun this and just double check here. We're going to rerun this one. And good. All right, and now here we are. All right, so again, it seems to not like this discrete allocation function for some reason. So I'm just gonna come up here. I'm gonna highlight that, copy it, come down here and paste it using Control V. So I just maybe had some misspelling there. There we go. All right, so I had some misspelling maybe that I couldn't see right away. And now it looks good. All right, so let's go ahead and continue. Okay, so next I want to compute how many shares of each stock to buy. Okay, so we're going to create a variable called allocation, and we're going to create a variable called leftover, and we're going to set this equal to da.lp underscore portfolio method. All right, so allocation, of course, will be the number of shares per stock, and then the leftovers will show the leftover money or cash that we have after allocating our $5,000 portfolio to these stocks. Okay, and you know what? We're going to print that actually. So let's print discrete, discrete allocation, and here we're going to put just allocation, and then I want to print the leftovers. So we'll say funds remaining, and then we'll put a $sign there because it's in USD, and we'll put leftover. All right. All right, so let's just run it. Let's just see. Oh, there's some problems here. So we have, can I import name discrete allocation from this here? So let's go back up and let's see what's wrong. So the problem is, oh, it looked like maybe I spelled it correctly down here and misspelled it up here. So discrete allocation there, and then discrete allocation here. All right, so now let's run this again. All right, now it looks like there's something wrong with get latest prices. And let's see, is get underscore latest prices. So let's see what our error message says. Missing one required positional argument, prices. Okay, so let's scroll up here. Get latest prices, and then here we need to get the latest prices of the data frame. So that's what it's telling us here. There's no prices here, so we need to get the prices of the data frame. So I need to put df here, and let's run it one more time. And there we go. Much better. All right, so now we can see our discrete allocations. It looks a lot better than the weights that we saw up here, right? This would have gave us a percentage, and down here we're getting the number of shares for each one of the stocks that we should buy, given $5,000, right? And their ending price, and the stock's ending price. So right now, it looks like the portfolio, which will be a $5,000 portfolio, is telling us to buy CBOE and buy 1 share of that. We should also buy KR, but specifically 4 shares of that. That's Kroger. LLY, we should buy 1 share of that. MCK, 1 share of that. So on and so forth. Okay. All right, but let's make it look even better. So let's store the number of shares allocated for each stock. So I'm going to create a empty list. So I'm going to create a variable called discrete underscore allocation underscore list. And once that is equal to an empty list, And then we're going to loop through our allocations. Okay, so we're gonna loop through our discrete allocations. So for the symbol, and that's CBOE or KR, LLY, those are our symbols. So for symbol in allocation, I want to pin the symbol to our discrete allocation list. So here I'm just going to type discrete underscore allocation underscore list dot append, left parentheses, right parentheses, and then we're going to input here allocation dot get symbol. Okay, and now let's create a data frame, and this will be for the final portfolio output. All right, so I'm going to call this data frame portfolio df, portfolio underscore df, and I'm going to set this equal to ed dot data frame, left parentheses, right parentheses. We're going to give it some columns. So the columns will be equal to a list here. And what will be in this list? Well, the name of our columns. So we're going to put here company underscore ticker. And then I'll put a comma here. I'm going to do discrete allocations or discrete values. Okay. And actually, let's make it even better. The let's add the amount that we're going to be putting into this portfolio. So we're going to put string portfolio underscore val. Yeah. So that looks, we're going to put the actual value there and not a string that says portfolio val. And then we'll put an underscore here as well. All right. So now it's going to say discrete underscore val underscore, and then I have whatever number we put here, in this case, 5,000. All right. Okay, now let's go ahead and add those values to our columns. So this is going to be easy as well. Just type portfolio underscore df. I'm sorry. Yep, that's right. Portfolio underscore df. And then we're going to put in our column name. That's company underscore ticker. And we're going to set that equal to our list. And it'll be a list of allocation dot keys. Okay, so here we're just adding the ticker symbols. All right, and then next we're going to basically do the same thing. It's going to highlight that, copy using Control V. I'm sorry, copy using Control C, and then paste it using Control V. And then here we're going to put our next column, which is right here. I'm just going to come up here, highlight it, copy it using Control C, come here and paste it using Control V. And we're going to set this equal to discrete underscore allocation underscore list. Right, that's the list that we created right here. Okay. And then I want to show the final portfolio. So we just type portfolio underscore df. All right, let's run it and let's see what it looks like. So there we go. We have our two columns, company ticker, and then discrete underscore val underscore 5,000. Our portfolio will be 1 CBOE, 4 KRs, 1 LOY, 1 MCK, 1 NEM, 1 NVDA, I'm sorry, 3 NVDA, 1 PWR, 1 STX, and 2 WMT. Okay, so we have Walmart and NVIDIA in here. All right, so that's the final portfolio that Python built for us, and it optimized it for the maximum Sharpe ratio and converted it into real allocations. And if you found this video helpful, please hit that like button, hit that subscribe button for more Python finance projects, and drop a comment if you want me to try this with crypto or ETFs or your own custom data set. You can also try it with your own custom data set, however you want to. So you can also get the code on patreon.com/computerscience, and I will leave a link for that in the description below. Thank you for watching, and I'll see you in the next video. Bye-bye.